Hey everyone, today we're gonna be doing a lead code question which is to create binary tree from a description. So they're saying you are given a 2D integer array description where it has three types of element, parent, child and a side, whether it is left or right. So here it is saying like it indicates that parent I has a child called child in a binary tree, and they are saying all the value will be unique. Okay, so furthermore they are saying okay, the is left in this particular array represent like whether if the is left is equals to 1, that means it is a left child. If it is equals to 0, that means it is a right child. Okay, fine. They are saying construct a binary tree with a description and return its root. Okay, they are saying there will be exactly like all the cases will be passing like it's a valid tree given to us which with this particular inputs. So we'll create a binary tree using this description array. After 1 second, we have two example. We'll look one. Here, if you see the constant, they are saying length of a byte like that description array can range from 1 to 10 to power 4. The description length is equal to 3. That means we have parent and child and the sides, whether it is left or right. Similarly, the parent and child can range from 1 to 10 to power 5, and the is left will range from 0 to 1. And they're saying the description given to us to create a binary tree is always a valid, like there will be exactly one tree will be created with a main root. Okay, so let's take the same example, the first one itself. I will draw this one like using that particular input. So if I say I have a description array, so if I say there's a description array, okay, given to us having some value. Okay, so I'll say this is one array, 2D array. It is having three types of value. Like there is like it is given 20 here. So let me write the first case over here. Like it will contain two types, like three types of element. What? Parent, parent of I particular. Similarly, there is a child I. Similarly, is left. There is one more parameter like is left for a particular ith child. Now, if I say I have a description array, okay. So if I say there is a description array, okay, description array has element. How many elements? So I can say okay, I have multiple elements. The multiple this description, it is having some child. I'll say okay, let's take like parent is 20, child is 15, and is left is 1. Is left 1 means it is a left child. If it is equals to 0, that means right child. Okay, so let me write that also over here. So is left means equals to 1, that means it is left. Let me say okay, left child. If is equals to what? If it is equals to 0, that means right child. Okay, fine. Now I have some inputs, so let me write that down also. So I have one child and parent like 20, 17, and is left is 0. Again, I have 50, 21. That means is child is right. Again, I have like I'll say let me create this particular a big array. Okay, I have one more array. Okay, fine, which is like 50, 80, and 0. Similarly, I have one more like 80, 80, 90, 80, 90, and not 90, it's 19 and 1. Okay, so I have this, you can say like I have these three elements for now. You can say these three nodes or the description. Okay, now each description have how many properties? I have one parent node, I have child node, and it is saying okay, is this child is a left or right? Fine. So for each of them, I have these three elements. First one means like it's a parent, it is a child, and it is a direction of that particular thing. Now, if I create this binary tree using this particular input, so let me say, okay, for this for the node, like if it is a parent, like if I take the first one, I have a parent as 20, child is 15. So I'll create one, you can say tree. So I have 20 as a parent. I have one child, 15. 15 where I'm checking is left. It is equals to 1. That means it is on the left side. So I'll say, okay, there is one left child, which is 15 for now. Now moving to the second input, I have another 20 as a parent, 17 as a right child, because is left is here 0. That means it is a right child. So let me create that particular node as well. So I have one more node called 20 with left right child 17. If you see here, like in this question, they have told us we have all the values as a unique. So instead of creating these two, I can even merge them. So for now, I'm just creating the pairs of like child and parent. Okay, so I'll create one more thing for this particular thing. Okay, parent is 50, parent is 50 with I have one left child equals to 20. So I have created one left child equals to 20. Similarly, for this one, I have parent 50, child 80 on the right side. So I create one more node 50, right side child is 80. Again, I have one child and parent, like 80 is a parent and 19 is a child node. Okay, so I'll create one more thing. So let me create like, okay, 80 is a parent node and I have one left side called 19. Now if you see over here, like these two belongs to same, this two belongs to same, and this belongs to this particular case. So let me merge this particular tree. So if I say coming from bottom, let's say, okay, I have one node 20, it is having one left child 15, right child 17. Okay, now I have one more, like this 50 has a left child 20, and it does also have a right child called 80. This 80 also have one left child called 19. So if you see over here, we have created this particular binary tree. So this is a binary tree generated from that input description. Now I need to return the root of this particular tree. So we have just created all the nodes, you can say, like I'm not sure which can be a root node. So if you see one thing carefully over here, each thing coming as parent and child, parent and child, parent and child. So we need to get one thing, like, okay, this 20 come as parent over here, but here it became what? Child. So if I say it came as a parent over here, here it become child. Similarly, it came as a child, it's remain child. Here it came as a parent, but here is also it is child. This came as a child, it remains child. Here it came as a parent. Here this came as a child, but here it has become parent. Similarly, this is a child, this is a parent. Now, if you see over here, I just need to get one particular node where it does not belong anywhere. Like I just need one node. Like if I say this particular node, I just need to check whether it is a parent and like it's only a parent. It's nowhere child in the particular range. So if I say this 20, here it was parent, but here it was becoming what? Child. 15 came as child itself, 17 also came child, 20 here it was parent, but here it became child. 50 over here came as a parent, here also it is a parent, here I can say like 80 came as a child, here it became parent, 16 and 19 it came as a child. But if you see, like 50 is only the element coming as a parent, that means I don't have parent to 50. That means if I have created this particular thing, I don't have any parent to 50. That means I can make this particular thing as a root node because it does not have any parent. So the same thing we need to identify. Okay, I just need a one node from here which only belongs to parent category, not a child category. So I can either create a set, like I can have two set, like, okay, so I can have one child set. So let me create one child set. Okay, child set, and I have a parent set. Parent set. Now if you see over here, like child set I'll create first. So I can say 15 was a child. So let me create 15 was a child, 17 came as a child, 20 became as a child, 18 came as a child, and 19 came as a child over here. Now parent array, parent set I'll say, okay, parent set. So let me remove this particular thing. Okay, I have one set called parent. 20 came as a parent, 50 came as a parent, again 80 came as a parent. Now, if you see over here, uh, I have three parents and five child. I just need a parent which nowhere became child. So what I can say, okay, in the set we have operation like I just need a you can say we have two operations like intersection and the union. So I just need an intersection of these, like I just need an element which is not present in this particular, like if I say for this element it should not present here. So I can do one operation like, okay, from the child set, or you can say from the parent side, I can remove all the child element. So if I say the 20 came in the child set, so it will be removed. 80 came in the child set, so it will be removed. 50 came in, nowhere came in the child set, so it remains over here. That means I have one element, it came over here. So that means I can simply use this particular thing and create one uh, you can say this particular, I can say it's a root node because it's only the parent with no extra parent over here, like it became nowhere child. So what I can say, okay, I can create this particular thing as a parent. Now if you see over here, I'm just getting this particular thing as a value. How can I create a tree from here? So from tree I have one data structure, like we are given some tree node where I have three types of value. Okay, so if this is at some data structure tree, I have one value property, I have some left property, I have some right property. Okay, so what I will be doing, like for each of this iteration for this 20, 15, and this particular left and right. So I'll say, okay, for parent also I will create some tree node. For child also I'll create some tree node, and I'll assign, like for this parent I have one child which this particular thing will be telling me whether it is a right or left. So I'll say for the 20 I have one left child, for 20 I have one right child, for 50 I have one left child, for 50 I have one right child, for 80 I have one right child, a left child. So I will be creating this using something, using this operator, but I just need to maintain this particular thing in some data structure. So what I will be doing, like I will be creating some hash set. Okay, so I will be creating some hash map where I will be storing this particular thing as a value. So this particular like element, I'll say, which is coming as a parent or child, I will be mapping its index to a some you can say node structure. I have this tree node, so I'll have some tree node as an address, but I will be identifying with some values like this. So I have some integer value which will be like pointing to particular tree node. Okay, so I can create this particular thing. So let me do one thing. Let me show you with some code over here how and what we gonna be doing in this particular thing. So let me create. So I will be using a hash map. Okay. So in Python, I can simply use a dictionary. Similarly, I will be using some set operations. I'll say, okay, I have some child set. I have some parent sets, and okay, for these two things, I can have this many things. Okay. So this will be what? This will be our sets. Okay, fine. Oh, okay. So I will be looping toward this particular, I can say, what we say, like a description. So I have this description. So I'll say, okay, for uh, parent, okay, for parent and child, and I'll say there's one more thing like is left. So I'll say I'll be iterating over this particular thing in this description. Okay, description array. Now, what I need to do, I need to check whether this belongs to particular set or not. So instead of checking, I'll simply append like, okay, for child set, I'll just append the child. Okay, so I'll just simply append the child. Similarly, for I'll say like for parent set, I will be appending the parent. Okay, so here it is a parent set. I'm just appending all the parents inside this particular thing. Okay, fine. Now I need to do one thing. Okay, I need to add this particular thing to my hash map. So I'll say, okay, hash map of particular like child. I will be adding some node. So I'll say, okay, there will be some child node. So I'll say, okay, child node. I will be creating this node, but for say like simplicity, I'll just write this whole thing. So this is my what? Parent node. Parent node. Here also for the parent value, I will be storing some parent node. This all will be some tree structure. Fine. So what I will be doing, like, okay, now I will be checking. Okay. what I will be checking, I will say, you can say if I have a parent node. So if I say if the parent is parent in, you can say, hash map. Do we already store the parent particular key in the hash map? If yes, then I will be taking something. If no, I will be storing other thing. So I'll say, okay, I will be using some list comprehensive or something. So I'll say, okay, for child node, for parent node itself, I'll say, okay, for parent, I'll say parent node. I have this parent node. I'll say parent node is equals to what? Hash map of parent. If we have this particular thing in the hash map, else what? We will be assigning a new tree node. Okay, so I will be creating a tree node with what? A value equals to, I have a value equals to what? Parent. Okay, similarly, I will be doing the same for the child node. So I'll say, okay, for child node, I'll say, okay, if this particular child is present in the hash map, then give me that address. Otherwise, create a new child. Okay, create a new child map. That sorry, child node. Okay, so hash map spelling is wrong. Okay, fine. Hash map. Now I have created what? Child address, parent address, and I have assigned this particular thing to the hash map. So whether it is already present or not, it will update the current thing. So one more thing left over here, like I need to check what I need to check. Okay, I just need to check if this is left is equals to true. I can say equals to 1. That means it is a left child. So what I need to do, I need to create a, you can say, root node, parent node. So I have this parent node. For this parent node, I will be having one left child. So I'll say, okay, left child should equals to what? The child node. Now, if it is equals to 0, that means else part. That means I just need to have this parent child assigned to its right instead of left. So I have created one left and right part according to the inputs. Now, what I need to do, I have I have created the set, I have created the hash map. Now, at last, I need to return a root. Okay, so I need to return root from a hash map. So I'll say, okay, whatever I have, I need to give a root of a particular tree node. So if I say I am just iterating over this value, that means I need to give that particular thing from a hash map, which have a node type of structure, like a tree node. So what I can say, um, let's say like, okay, I have that particular thing, like let's create a root. Root will be what? I'll say, okay, from the parent sets, just remove the child set. So there will be exactly one parent which is not child anywhere. Okay, so this will have a one single element inside a hash set. What I can say, okay, I'll say just root dot pop. So whatever left behind will be our answer. So let me run this code. Let me see if I have any code or something. So description is spelling is wrong. Okay, copy, paste. Let me compile this code again. Uh, so it's running successfully. You can see over here, like I'm just getting the same expected very well. So let me submit this code as well. Mhm. So I can see like this code runs successful and it's optimized as well. So yeah, let me talk about the time complexity and the space complexity for it. So for this particular thing, like we are iterating over this description array exactly once. Okay. So the time complexity is like order of n or order of description, the length of a description array. Similarly, for the space complexity, like we are storing that particular thing as a parent and child and also a hash map sort of thing, or maybe if, whenever you are creating a tree, it will like order of height, you can say. So that will be our space complexity for this part. So yeah, that's all for today's. Thanks for watching.